Hi everyone, this is Dr. Maheshwari. Welcome to my channel Tech Tutor for You. Today I'm going to discuss about amplitude modulation and its analysis. Analysis means a representation of the corresponding modulation technique. It has three representation. So one of the major representation is a mathematical representation of amplitude modulation. So I'm just naming it up mathematical analysis of amplitude modulation. So in this video, I'm going to talk about amplitude modulation and its mathematical analysis alone. It has two more representation that will be given in the separate videos. So coming to the topic, amplitude modulation. This is one of the continuous wave modulation. Amplitude modulation is one of the continuous wave modulation. It is generally noted as AM. The general definition of amplitude modulation is varying the amplitude of the carrier signal with respect to the instantaneous value of the modulating signal. This process is nothing but we are going to change the amplitude of the carrier signal with respect to the amplitude of the modulating signal. So under the amplitude modulation, we have two input signals. One is message input signal, another one is a carrier input signal. It is a low frequency input signal and this is the high frequency input signal. I have already given a video about the input signals, message, carrier, or a type of a signal, analog and digital, or type of a modulation. I have given that link into the description box. If you want, you can kindly check it. Here, here I told you the definition is, the definition for the AM is the amplitude of the carrier signal is varied with respect to the modulating signal. The other two parameters of the carrier signal is frequency and phase. That should be kept constant under the amplitude modulation. This is the general definition behind the amplitude modulation. In simple manner, I am going to explain the amplitude modulation by means of a simple schematic. Consider this block as an amplitude modulator. Modulator is nothing but modulator is used to perform an operation which is called as a modulation. A particular modulator is used to perform a process called amplitude modulation, means that is called as an amplitude modulator. So an amplitude modulator needs two input signal, message and carrier. So after the process completed, it is going to produce an output signal as amplitude modulated signal. Under the mathematical analysis, all the input signal to be expressed in terms of time domain manner. So any signal can be expressed in terms of time domain, means you have to consider the shape of the signal. Coming to the next slide. This is your modulating signal. We are taking the modulating signal as the low frequency signal is the continuous time signal. If it is a continuous time signal, means the shape of the signal may be sinusoidal type or a cosine type. So the general notation is a sinusoidal wave. So mathematically, the sinusoidal wave can be represented as with respect to the peak to peak amplitude. Positive peak amplitude of the corresponding input signal as notated as a small v. The corresponding negative peak amplitude as a minus small v. V represent an voltage or the amplitude of the corresponding input signal. Since it is a message signal, I am taking it as the positive peak amplitude of the message signal as small vm. Similarly, the negative value as minus small vm. So this is the peak amplitude of the corresponding input message signal. So mathematically, the voltage expression for the message signal can be represented as capital V of t is equal to, that is capital Vm of t is equal to small vm sine omega mt. Small vm is nothing but peak amplitude of the message signal. So instead of V, so many parameters are given, which is nothing but A or E, all represents which is nothing but amplitude or magnitude of the corresponding signal. So Vm of t is equal to Vm sine omega mt. Omega is angular frequency of the corresponding message input signal. Similarly, the high frequency carrier signal can be noted as or can be given as mathematically Vc of t is equal to small vc sine omega ct. This is nothing but peak to peak value of the corresponding carrier signal. Carrier signal is nothing but high frequency signal. High frequency signal means it should be plotted with respect to the lowest time period. Anyway, this is the sinusoidal carrier signal. The corresponding voltage expression, this is your peak amplitude of the carrier. This is the angular frequency of the carrier. So these are all the two inputs of the amplitude modulator. One is Vm of t, another one is Vc of t. So under the amplitude modulation, exactly this process is going to be done. In simple way, the two frequencies are low frequency signal and high frequency signals are superimposed under the amplitude modulation. Superimposed means one above the another. The frequencies one above the another is going to be carried over. That is omega, that is Fm and Fc are present under the amplitude modulators. The two frequencies are superimposed. So at the another end, that is going to be represented as a frequency omega c or sine omega ct. Since it is superimposed, the sine omega ct is the mathematically sine omega ct is represented at the output of the amplitude modulator. So under the amplitude modulator, the process amplitude of the carrier is going to be varied. So amplitude of the carrier is Vc. Is going to be varied means that should be reflected at the output. So the amplitude of the carrier is going to be varied. The frequencies and the frequency of the carrier and phase of the carrier is not going to be varied means that can be reflected at the another, that cannot be reflected at the output, which means the same sine omega ct is presented over there. If it is superimposed means the low frequency signal is also present inside the high frequency signal. So by mathematically sine omega ct is presented at the output of the amplitude modulator. Therefore, where is the change we can able to find? Change in the amplitude of the carrier signal. The amplitude of the carrier signal is going to be varied with respect to the message. That can be represented as small VAM. That is amplitude of the AM wave. Amplitude of the AM wave is noted as small VAM. So hence I have written this as VAM of t is equal to small VAM sine omega ct. May be the output representation of the amplitude modulated wave. Coming to the detailed analysis of the amplitude modulated wave, it is the mathematical representation of AM or mathematical analysis of AM. So under this analysis, there are two domain analysis. One is time domain, another one is frequency domain analysis. Under the time analysis, we have this assumption. One is a message signal, another one is a carrier signal, another one is the amplitude modulated signal. Already we have seen this. This slide, according to the definition, how the carrier voltage is varied. The carrier voltage is varied means it may be increased or decreased. It is not needed to produce your output in terms of a decreased value theoretically. So it is enough to produce your output or to give your output in terms of positive representation. So under the amplitude modulation, according to the definition, the carrier voltage is going to be increased with respect to the message. What is your message? It is Vm of t, that is nothing but Vm sine omega mt. That is nothing but the amplitude of the amplitude modulated signal. We know that Vm of t is equal to Vam sine omega ct. Substitute the value of Vam over here. We will get Vam of t is equal to Vc plus Vm sin omega mt into sin omega ct. Go for the simplification. Go for the simplification. Take down Vc outside. We will get 1 plus Vm by Vc sin omega mt into sin omega ct. So from this expression, we will get a very important relation which is called as a modulation index for AM. That is the ratio between peak amplitude of the message signal and the peak amplitude of the carrier signal. That is Vm by Vc, which is equated to a modulation index which is notated as MA or capital MA, whatever it is. M suffix A represent as a modulation index for the amplitude modulation. So the output is Vc into 1 plus MA sin omega mt into sin omega ct. So the final outcome can be represented as Vam of t is equal to Vc sin omega ct into 1 plus Ma sin omega mt. Kindly make a note, that is the final expression under the time domain analysis. That is your last expression, which is Vam of t is equal to Vc sin omega ct into 1 plus Ma sin omega mt. So the next analysis is a frequency domain analysis under the mathematical representation. Why we go for frequency domain analysis means to plot a spectrum which is called as a frequency spectrum, which is nothing but representing all the frequencies. So representing a signal, that is your output signal, in terms of a frequency domain is a frequency spectrum. So we got your output signal under the time domain analysis is this expression. For simplification, do ordinary multiplication. So we will get Vc sin omega ct plus MAVC sin omega ct into sin omega mt. So it is in the form sin A sin B format. So apply the mathematical formula. Sin A sin B is equal to cos A minus B minus cos A plus B divided by 2. Instead of A we have omega c. Instead of B we have omega m. So after applying a mathematical formula, we will get Vm of t is equal to Vc sin omega ct plus Ma Vc, taking 2 outside, into cos omega c minus omega mt minus cos omega c plus omega mt. We know that omega is equal to 2 pi f. Therefore, omega c is equal to 2 pi fc and omega m is equal to 2 pi fm. Substitute in that expression. So we will get Vc sin 2 pi fct plus MAVC by 2 cos 2 pi fc minus 2 pi fmt minus cos 2 pi fc plus 2 pi fmt. Again for simplification, taking 2 pi outside from this expression, so we will get this expression. That is only taking 2 pi from this expression alone, here and here. We will get an expression like this. And do a simple multiplication, putting MAVC by 2 multiplied with respect to these two internal terms. Finally, we will get your output expression for amplitude modulated wave, which is Vam of t is equal to Vc sin 2 pi fct plus MAVC by 2 cos 2 pi fc minus fm of t minus MAVC by 2 cos 2 pi fc plus fm of t. That is, under the frequency domain analysis, 3 frequencies are identified. One is fc, another one is fc minus fm, another one is fc plus fm, which means one frequency has center frequency, another frequency is lesser than center frequency, that is subtracting the value of fm from fc. Another one is adding the value of fm with respect to fc, means which is greater than fc. So one frequency is a carrier frequency, can be considered as fc. Another frequency is greater than fc is fc plus fm, lesser than fc is fc minus fm. That will be called as LSB and USB. LSB, here I noted no, LSB is lower sideband, USB is upper sideband. USB is upper sideband. So finally, amplitude modulation output expression comprises of three terms. One is carrier, another one is LSB, another one is USB. So addition of carrier component, LSB component, USB component comprises an output called AM. So usage of frequency spectrum is plotting a spectrum between a frequency and amplitude. So taking frequency at your x-axis and taking amplitude at the y-axis. The three frequency components are FC, only the frequency components, FC, FC minus FM and FC plus FM. Randomly, we can consider the FC as the center frequency. Frequency have only positive value, it is not zero or it has no negative value. So hence, you can randomly put a value at the x-axis as the center frequency. One is lesser than FC is FC minus 1 and another frequency is greater than FC as FC plus FM. Correspondingly, the coefficients of the frequency components are VC, MA VC by 2, MA VC by 2 again. Only the coefficient or the magnitude of the corresponding all the frequencies to be plotted at the y-axis. One is the carrier voltage. Any constant value can be kept over here, that is the carrier voltage. And MA/VC by 2 means under the amplitude modulation, consider the value of MA for the understanding purpose alone. If you are considering MA is equal to 1 or less than 1, not greater than 1, that is not acceptable under the amplitude modulation. So theoretically, we can keep the value of MA is equal to 1 or less than 1. If it is greater than 1 means that can be considered as over modulation. Anyway, if you are considering MA is equal to 1 means it is 1 by 2 VC, definitely it is lesser than VC. So for that assumption, this plot has been made. So for that only I am just explaining this, the value of modulation index, that is the separate topic. Anyway, MA/VC by 2 means under the amplitude modulation should be less than carrier voltage. So plot the value anywhere should be lesser value under the amplitude modulation in the frequency spectrum plot. So connect or coincide all the values, you will get the plot like this. So you can understand for the LSB and USB, the magnitudes are same. So this is nothing but a frequency spectrum plot or the spectrum of the AM wave. What is the usage of frequency spectrum, which is used to calculate the bandwidth of the corresponding output amplitude modulated signal? Bandwidth is nothing but, we know that it is the difference between higher order frequency and lower order frequency. Here the higher order frequency is FC plus FM and lower order frequency is FC minus FM. So subtract this value from this, you will get 2 FM. So in terms of hertz, the bandwidth of FM is very, very important. It is equal to 2 FM. You can also plot this frequency spectrum in terms of omega. So instead of F, you can substitute omega. So it is the omega C plus FM, omega C minus FM. Instead of frequency, you have angular frequency. You can put angular frequency, that is omega. Do the same procedure, you will get the bandwidth of the AM wave in terms of omega is 2 omega, unit is radians. Thanks for watching this video.